Hello, friends. I am Gaurav, and I have talked about black holes many times. We know that if something crosses the event horizon once, be it an asteroid or a comet or a planet star or even light itself, it can never come out again. This means what is going on outside the black hole. We have a pretty good idea about it, but we still don't have any way to look inside it. But yes, there are some speculations. Want to know my favorite one? Look, if you want to imagine the view inside a black hole by applying a little logic, then it is quite simple. Pause this video for 2 seconds and look around you. Didn't understand? Well, according to this theory, our entire universe is inside a black hole. Can't believe it, right? Well, look at this paper. This paper was published in 2014 by American scientist Nikod M.J. Poplos. No, it is clearly stated that our universe is also inside a black hole. I know this is a crazy allegation, right? So let's find out the truth behind this. Let's start with a basic fact that how does a black hole form? I know I have explained this many times before, but still, let's do a small revision. Every moment inside the core of every star, some kind of etc. force situation is being created between nuclear fusion and gravity. Basically, what is happening in the core of a star? In the core of a star, nuclear fusion reactions and the energy released from nuclear fusion reactions prevent the upper layers of the star from collapsing inwards due to gravity. And as soon as the fusion fuel starts to get exhausted, there is no nuclear energy left to fight the inward force of gravity. And if the star is very massive, then its entire mass collapses inwards on itself. That is, it implodes inwards on itself. And that star becomes, yes, a black hole. Yes, a black hole. Now, we know that there is a singularity inside every black hole, a point of zero volume and infinite. According to scientists, everything that falls inside the black hole becomes a part of this singularity. Let me tell you, this is not the only singularity. Yes, the singularity that you see inside the black hole is not the only one in the world or the universe. There is another type of singularity which we call the Big Bang singularity. Yes, as I have mentioned earlier in many videos, our universe is expanding, that is, things are moving away from each other, but in the 90s when Stephen Hawking tried to imagine this expansion in reverse, he noticed an obvious thing. All the matter must have been part of a very small, infinitely dense region at some point in time, an infinitely dense region which is nothing but a singularity. That is, from this singularity of singularity, it does not seem that there is any connection between a black hole and a Big Bang. The only problem here is that the singularity of a black hole pulls things towards itself, and due to the similarity of the Big Bang, things are expanding outwards, so both are totally opposite to each other here. So can we compare these two? Well, not directly, but there is another celestial object which can solve this problem. A white hole, the completely opposite twin of a black hole, throws things out, and if any object has to enter a white hole, it will have to travel faster than the speed of light, which is again not possible. And interestingly, mathematical models of white holes have also revealed that white holes also have singularities. So did our universe also form from the singularity of such a white hole? If yes, then where did the matter enough to create the entire universe come from inside this white hole? Well, according to some theories, black holes and white holes are actually connected. And this connection is their point of singularities. Yes, they both share the same singularity. That is the singularity which pulls things inwards in a black hole. The same singularity pushes things outwards in a white hole. That is, it is possible that a new universe can be created from all the matter that falls into the black hole, and this very idea has been used in the theory of second universe. In 1992, physicist Telis Malone published a hypothesis in a book called Life of the Cosmos. It was called Cosmological Natural Selection, also called second universe. According to that theory, whenever something crosses the event horizon of a black hole, it becomes a part of the singularity. Over time, the mass and size of the singularity starts increasing by absorbing matter inside it, until eventually its matter-absorbing limits are crossed, and an extremely large mass appears on the other side of the singularity. Explosion gives birth to daughter universes. This new universe will be independent of the previous one, in which the process of universe formation will start again. It will form its own stars, its own solar systems, galaxies, and its own black holes. And these black holes will once again give birth to new universes inside them. And this cycle will start again. So, according to this theory, inside every black hole In fact, inside the two black holes whose picture we have taken, there are whole universes present. We can also conclude from this that perhaps our universe is also inside a black hole. What do you think about this theory, guys? But all this will come to your mind that Gaurav, that thing is true, but this is a hypothetical. Who is up to write this without any mathematical proof to it? Well, not really. British scientist Dr. Roger Penrose had given a mathematical and graphical proof of this theory in the early 1950s with the help of his Penrose Diagram. The graph of Penrose looks something like this. Too much to handle, right? Don't worry, I am here to tell you how to understand this graph in very simple language. If we need to find the position of anything, we usually use a 2D or 3D graph. A 3D graph tells us where an object is located, but to get the answer to when it is located, we have to add one more dimension. Now, the problem here is that we humans who are living in a 3D world and have evolved to perceive only 3D objects cannot even imagine 4D, leave alone making a 4-dimensional graph. But still, German mathematician Hermann Mann succeeded in converting space and time into a 2D graph. Today, we call these graphs diagrams of mangoes. For this, what he basically did was to combine the 3 dimensions of space and bring them on the x-axis and put time on the y-axis. Now, if I try to draw myself on this graph, then right now I am sitting at the same place. That means my position is not changing, but still time is moving forward. 1 second per second. My path in this graph will look something like this. Now let's add some speed to it. The faster my speed, the faster my position will change, and the more my angle will increase with time. Minkowski has scaled the angle of this graph in such a way that the pack of light will make an angle of 45 degrees in it. And according to the rules of the universe, nothing can travel faster than light. That is, the path of all other things in the universe will be triangular of 90 degrees. It will remain in the region only. Basically, it means that we can travel only in this much region, or we can perceive only this much region, and we can create a similar region in the opposite direction as well. The triangle above this is our future, and the one below this is our past. If we imagine these triangular regions in 3D, we get a cone, and that is why these regions are called light cones. Neither can we travel outside the walls of these light cones, nor can anything enter inside these walls, because for both we will have to travel faster than the speed of light, which is obviously not possible. So the area that is coming under the upper cone is basically our future is the observer universe, and the part that we can perceive in the past is the cosmic microwave background radiation of the universe. So now we know how we can plot the 4D space-time. But the problem does not end here. The angle and orientation of the light cone is not always constant. Let me explain. Suppose we are going near a black hole, then it is obvious that we will slowly be pulled towards the black hole. And the main problem arises here. Even light gets bent by the black hole. That means our light cone will start getting squeezed and tilted towards the black hole. Now, as we keep falling inside that black hole, our chances of getting out of the black hole will keep getting less and less. And as soon as we cross the event horizon, then we will have to say goodbye to this universe forever, because our future light cone is now completely inside the black hole, so there is no way out. But honestly speaking, every astrophysicist, all a scientist needs is to be able to peek inside a black hole. But because of the tills of the light cones, scientists face some difficulty in understanding it. Scientists needed an easy solution for this also, and this is where Dr. Roger Penrose's game comes in. To save the symmetry of light from the curvature of space-time, Penrose bent the axis of the graph itself. Now, you must have heard this line in your school math period. Parallel lines meet at infinity. Penrose made this graph using the same technique. I know it is a little difficult to understand this in a 2D graph. I mean, after all, we are trying to visualize a 4D object in 3D and then draw it in 2D. But let me give you an example. Imagine you have a ball on which a chessboard-like design is made. The area of each square in it is equal to each other. But when we place that ball directly in front of the face, we see that the squares in the front are bigger, and at the edges, these squares are getting smaller. This graph also works in a similar way. By bending the background of the graph, Penrose fixed the structure of light cones. That means they could be understood more easily now, and with the help of this diagram, Penrose proved mathematically that, yes, a complete universe can actually exist inside a black hole, and not just a complete multiverse. Mind-blowing, right? I mean, multiverses in a black hole. But let me tell you, As much as this concept is mind-blowing, it is equally difficult to understand it accurately, but I hope I was able to explain this concept to you a little bit. So now, after listening to all this and imagining in your mind, do you think that our amazing universe is really contained inside a black hole? Write your answer in the comment section below. What do you think? Do you agree with this theory or not? And if you learned something new from the video, then definitely give a like. Stay. You and your friends keep learning and keep growing.